Welcome to this lesson video. Today we'll be looking at geometrical optics. We are going to look at the study of light. We are going to talk about the properties, how it behaves. We look at the equations. We look at the Snell's law. We will also discuss critical angle. We'll be looking at angle of incidence, angle of refraction, angle of reflections. Now let us start. Our first basic knowledge we need to know is the speed of light. Now remember, in this chapter we are dealing with the study of light. We all know that we have different types of rays. For example, we have gamma rays, we have ultraviolet rays, we have the microwaves, the X-rays. So specifically we'll be looking at the light. Now before we continue, we have our first equation. Please write it down. We are going to use it. Now let us explain this equation. N stands for refractive index. It's a refractive index. Now, what is a refractive index? Refractive index of a material is the ratio of the speed of light in vacuum to the speed of light in a material. When I say in vacuum, I refer to the speed of light in the air. Now material, I'm referring to different types of material. It might be a diamond, it might be water, it might be cooking oil or oil, different types of materials. Each and every material has its own refractive index. Now, in order for us to calculate the refractive index of a specific or a certain material, we need the speed of light inside that material. We also need the speed of light in vacuum. In most cases, the speed of light in vacuum, it's a constant value, which the maximum value is 3 times 10 to the power 8 meters per second. That is the speed of light. Speed of light, which is represented by letter C, which is the speed of light in vacuum. The maximum value of the speed of light, it's 3 times 10 to the power 8 meters per second. That is equals to C. Write this down, is very important. Now V is the speed of light in a material. Now remember the definition of refractive index, which is N. The refractive index of a material is the ratio of the speed of light in vacuum to the speed of light in material. So basically, this definition explains this equation. This is the ratio. C over V, it's equals to our refractive index. Let us look at how we use this equation. Our first question: Let's say we are given this scenario whereby we have a substance. Its refractive index is 1.4729. Calculate the speed of light inside this substance. Now we use this equation, N is equals to C over V. We are given the refractive index, so which is the refractive index, it's 1.4729. So we simply substitute our refractive index. It's equals to the speed of light we are always given. It's a constant number all over V. We are looking for the speed of light. From here we need to solve for V. Actually, let me write it here. 1.4729, it's equals to 3 times 10 to the power 8 over V. Now we are trying to solve for V. What we are going to do, we are going to multiply both sides by the term or the number causing the fraction. This is mathematical operation now. So we can see that the term which is causing the fraction is V. So we multiply both sides by V. Now this will result into 1. 1 multiplied by 3 times 10 to the power 8. It's 3 times 10 to the power 8. V multiplied by this number is 1.4729 V. From here we are going to solve for V. So we divide by 1.4729 both sides. So this will result into 1. 1 multiplied by V, it's V, it's equals to. We simply punch this on the calculator, we'll get our answer. So the speed of light is 203679815,3 meters per second. We are done with this question. Let us go to the next one. Light is projected inside the water. The refractive index of the water is 1.3. Now I believe you are asking yourself, what is the SI unit of the refractive index? Now the answer to that question, refractive index doesn't have SI unit. Let us quickly explain why. Now as you can see, the equation is N is equals to C over V. What is the SI unit of C? It's meters per second. Then what is the SI unit of V? It's meters per second. Now you can see that this will result into 1. Then it means the SI unit of refractive index, we cannot say it's 1, but we can also say it's 1. Now let us answer this question. Feel free to pause the video. Try to work out the speed of light inside water when you are given the refractive index. After working out the question, you play the video and verify your answer. Now the first step, we need to write the equation. Then we are given the refractive index. We are given this. We are given this automatically, so we're looking for V. Now we have 1.3 is equals to 3 times 10 to the power 8 V. Like the previous question, we are solving for V, so the term or the number which is causing the fraction, we multiply both sides. So this will result into 1 multiplied by 3 times 10 to the power 8 is 3 times 10 to the power 8, and then we have 1.3 V We divide both sides by 1.3. This will result into 1 multiplied by v. It's simply v is equals to, we punch this on a calculator, we get 'I hope you got the very same answer. Now we are done with this question. Let us go to the next one. Okay, here's another example. We are given the refractive index. We are looking for the speed of light inside the material. So the equation is nc over v. We are given this and this. We are looking for v. So 1.0 is equals to 3 times 10 to the power 8 over v. Multiply both sides by v. This will result into 1. Then let me change the color. Then have 3 times 10 to the power 8 1,0 v. Both sides. This is the final answer. The next part of the lesson video, I want us to talk about the refractive index of the air. Now, for some reason, the refractive index of the air is always 1,0. Now we can prove this using our equation. N is equals to C over V. Now N is equals to, C is the constant, 3 times 10 to the power 8. Now what is the speed of light in the air? Now since we know that V represents the speed of the light in the material, C is the speed of light in the air. So in this case, our material is the air. So what is the speed of light in the air? It's still 3 times 10 to the power 8. Now what is 3 times 10 to the power 8 divided by 3 times 10 to the power 8? It's simply 1,0. That is why the refractive index of the air is 1,0. In this chapter, we have what we call normal line, angle of incidence, angle of refraction. Now, before we go to this normal line, angle of incidence, and refraction, let us furthermore explain this refractive index. Now, in this chapter, we have what we call optical density. There is a relationship between refractive index and the optical density of a material. Materials with high refractive index will also have high optical density. Now, for example, the first question in our examples, we saw that the refractive index was 1.4, and then our last example, the refractive index was 1.0. Now, comparing the two materials based on the refractive index, we can see that the first material, it has high optical density compared to the last material. Why? Because the higher the optical density, the higher the refractive index. I hope it makes sense. Now let us get to normal line, angle of incidence, and angle of refraction. Now what is normal line? Simply write this definition down. A normal line is the line which is perpendicular to the plane of the surface. For now, simply write this, and then we will explain in terms of pictorial. Normal line is the line which is perpendicular to the plane of the surface. Angle of incidence, the angle between the normal line to a surface and the incident light ray. Simply write this down. What is the angle of incidence? The angle between the normal line to a surface and the incident light ray. What is the angle of refraction? Angle of refraction, the angle between the normal line to a surface and the refracted light ray. Let me repeat this. The angle between the normal line to a surface and the refracted light ray. I hope you understand. Actually, I hope you wrote these definitions down, and then I'm about to make you understand more about this. Now let us try to explain those three terms. Now the normal line, it says, is the line which is perpendicular to the surface. Now you can see the green light, the green lines, these lines. This is what we refer to the normal line. You can see that it's perpendicular, it forms 90 degrees with the surface of the medium. Now the yellow line, this is what we call the incident ray. Remember, we have incident angle and incident ray. And then the red one, we call it a refractive ray. Now looking at the angle between the normal line and the incident ray, which is this angle, this is what we call the angle of incident. And then the normal line and the refracted ray, this angle, we call it angle of refraction. Now don't confuse the angle of refraction and the angle of incidence. Also don't confuse the incident ray and the refracted ray. Now the incident ray, as you can see that we are trying to explain the behavior of light from one medium to the other, from one material to the other. Now you can see that the light was projected. As it was projected from the source, it travels from one medium to the other. So the first medium which is traveling in, that medium will consist of the incident angle and the incident ray. As the very same light enters the other medium, inside the second medium, it's where we talk about the refracted, the angle of refraction and the refracted ray. I hope you understand. So it depends on which material the light travels in first, and then we look at the second one. The first one is associated with the angle of incident and the incident ray. The second material will be associated with the refracted ray and the angle of refraction. Suppose the light comes from this direction. So it simply means that our normal line will not be here. will be here. Then this is where we will be indicating our refractive angle and our incident angle. Next part of this lesson video, we are going to talk about Snell's law. Now there is a law in weights, and then as we all know that in physical sciences, each and every law is accompanied by an equation. Now Snell's law states that the ratio of the sine of the angle of incidence in one medium to the sine of the angle of refraction in the other medium is constant. Write this down. The ratio of the sine of the angle of incidence in one medium to the sine of the angle of refraction in the other medium is constant. Now this is our equation. Ni is the refractive index associated with the incident ray. Remember, we have two mediums. Two mediums, they both have different or the same refractive index. So the light which is traveling in the first medium, which is associated with the incidence, its a refractive index in this equation, it's Ni. Actually, there's a problem with this equation. Let me rectify it. It's not sin I, sin R. In fact, it's theta I, theta R. I hope you can see this. Now it's correct. Now this angle, let me quickly change the color. This angle is the angle of incidence, the one I just showed you in that picture. And then NR is our refractive index of the refracted ray. QR is the refracted, is the angle of refraction, in fact. I hope you can see this equation. Write it down. This is the Snell's law. Now our first example on how to use the equation, Snell's law. Suppose we have this scenario whereby we are given one of the angles, we are given all the refractive indexes, and then we're looking for one of the angles. Now how do you analyze this? We can see that we have the refractive index of the incident, we have the incident angle, we have the refractive index of the refracted. So you're looking for the refractive, the angle of refraction actually. So writing the equation Ni sin theta I is equals to Nr sin theta R. Analyzing our scenario, we can see that we have this, we have this, we have this, we are looking for this. So we can simply substitute and find our answer. So the angle of incidence is 27 degrees. The refractive index of the incidence is 1.25. We have sine 27 degrees equals to our refractive index of the refracted, it's 1.34. Sine theta R. Then we can work out the angle. So how do we do that? We divide both sides by 1,34. Now this will result into 1 multiplied by sine theta r, it's sine theta r, is equals to 1,25 sine 27 all over 1,34. And then remember, this is a trig ratio. How do you remove sine from theta r? Removing sine from theta r, you are left with theta r, and then we have the inverse. Let me actually write it like this: 1,25 sine 27 all over 1,34. Then we simply punch this onto the calculator. We will find our answer. So let me quickly punch 1,25 sine 27. Then I have 1,34. So the angle of refraction is 25. Rounding off to the nearest, it's simply 25 degrees. This is how we use the equation. Let us go to the next example. Our next example, we are given this scenario. Now I'm not going to say much. The question: calculate the angle. Well, according to the scenario, we have signs which indicate whether we are looking for QR or QI. Just go through the question and try to answer the question. Remember, you pause the video, you work out the question, and then you play the video, you compare with your answer. Now in this case, we can see that the light is traveling from the yellow colored material to the green colored material. So it means the yellow colored material is our incidence, and then the green colored material is our refractive. So we are given the angle of incidence, which is 37 degrees. We are going to calculate the angle of refraction. Now our equation, Ni sine theta I is equals to Nr sine theta r. We have 1,47 sine 37 is equals to no, there's a problem. I think I made a mistake. It's 1,33 sine 37. And R is 1,47 sine QR. From here we divide both sides by 1,47. This will result into 1 multiplied by sine theta r, it's sine theta r. Then this side we have 1,33 sine 37, 1,47. Inverse 1,33 sine 37 all over 1,47. Three multiplied by sine 37 . Answer is 33 degrees. I hope you got this one correct. Our next part of the lesson is critical angle. We should know what is critical angle. Now, the definition of critical angle is the angle of incidence in the optically denser medium for which the angle of refraction in the optically less dense medium is 90 degrees. Now we should understand this critical angle. Critical angle is the angle of incidence in the optically denser medium for which the angle of refraction in the optically less dense medium is 90 degrees. Now we can see that medium one, we have medium 2. Medium 1 is associated with incidence. Medium 2 is refracted. Now, what is critical angle? Critical angle, it's not this angle. No. Critical angle is the angle of incidence, of which the angle of refracted is 90 degrees. If the angle of refraction is 90 degrees, then it means this angle of incidence is our critical angle. I hope you understand this. Some of the misconceptions is that this 90 degrees, the angle which is 90 degrees, it's our critical angle, of which is not correct. The angle of incidence, whereby the angle of refracted, actually the angle of refraction is 90 degrees. That angle of incidence is our critical angle. That's it for this lesson video. I hope it is helpful. This is Bahula SJ. Thank you very much.